For the second part of Autodesk 3ds Max Design 2011 Design Visualization Workflow for Civil, we'll have a look on how we can reload the data and look at the design changes. We'll then load traffic simulation into a dataset. We'll create daylight system and render a still image using Mental Ray. So let's get started. Okay, so far we have a model that it's getting quite advanced here. So we have moving cars, we have lampposts, road markings, multiple objects including bridges and barrier, retaining wall. We have a railroad system including an animated train. But now we just learned that the civil people have been updated the plan and we need to update our visualization to follow the design changes. No problem, we'll do that in just a second and everything will be updated automatically. So if we look into the perspective view, you'll see that there's quite a bit of height in between those two corridors. So we're going to reduce the height amount in between those two corridors and bring back Pemberton Way a little bit closer to the ground surface. So let's open the Import Object Manager. In this window, you'll have a list of all the objects that you've been imported in the first import when we're dealing with the import window and selecting all the feature and components to import. All of these objects keeps a direct link to the .vsp3d drawings. So you can see here that it's pointing to this file. Now, if we look at the import folder, you'll see that there's a design plan adjusted .vsp3d that has been exported by the Civil 3D team. So I now want my visualization to point to this plan that has been adjusted. So let's just do that by selecting all the objects in my Import Object Manager. So you see all the objects are selected now. And instead of pointing to the original .vsp3d, I'm going to right-click and change the source file association and point to the design plan that's been adjusted. So it's telling me if I'm sure that I want to point to that one, I'm going to say yes. Now it's pointing to that file, but it still hasn't been updated. So I'm going to select all my object again, right-click and update selected objects. So it's going to go through all the objects and look if there's any difference in both of these drawings, and it will update automatically these objects in my scene. So it's telling me here that the source data of these objects has been successfully located, and it's asking me if I want to update these. So I'm going to say yes, and it's going to go through the update process. Once the update is completed, it's telling me that 121 imported objects have been successfully updated. I'm going to close this window, and still in my perspective view, I can see the result of these changes here. So the road is now a little bit lower and closing to the ground surface. But moving back to my camera, I see that all my camera are still there. I still have all of my objects, and all of my objects are following this update. So cars, road marking, lamppost, everything that I have included in this scene is following now the update. Now I understand it's a little bit hard to see visually the result of these updates, but I have saved some images here. So you see here an original rendering that I've created from this file and the result of the design change. So you see here that the road highway is a lot lower and you can see the design change in this file. Another angle to help you understand the result. So this is the original drawing and the updated drawing. So you see that the highway is now lower, but still everything that I have included in this file is following those design changes, including retaining wall, bridge structure, and everything that is included in this file. Alright, so let's move this visualization a little bit further here. So you see that the Pemberton corridor is the corridor that I'm working on the design the most. But Enfield Road, the exit road, the roundabout, those are all existing roads, and there is existing traffic data information that I was able to find for these existing roads, and I'm going to load this traffic data information, which is a .fzp file that you'll find in the folder structure. So let's load this traffic data information and really increase the validation of our design. Okay, so we'll move to a top and wireframe view and go to the Dynamite VSP menu, Traffic Import vsim FZP file. This will open the import window where we can point to the vsim file, which is located under its folder. The first window that opens up is for the time resolution filter. So basically, you can have a really dense keyframe animation, which is how the animation has been recorded, which is really high quality, or you can go to a lower quality by adding less keyframe in your animation. So we're going to go to a medium quality of 1. So we have a certain amount of keyframe, but it's not too dense for our data. Then it's going to point you to all the cars that are part of this traffic data information and that have information that have been recorded. So you see that there's 2 different type of cars, so probably trucks and cars, so different types. So I'm going to select all the cars because I want to import them all, and I'm going to leave everything else to the default setting and click OK. So this other window is telling you that this particular traffic data information has recorded a total of 7,500 frames. It's not fitting in your scene because your scene only have 2,033 frames. So it's telling you, do you want to adjust your time frame to match the traffic data information? But for this particular example, I don't want to adjust my time frame. And there you go. You can see all the little cars have been imported here. So you're going to wonder why they haven't been imported at the right location. It's because I didn't change the global shift value of this file because I've never used this file before. So I did not know the global shift value that this file needed to be moved at. So what I'm going to do is I'm going to select all of these cars, and you'll see that they're really easy to select because they all have the name DSIM in front of the car. So I can select all of these cars and group them into a temporary group for now, and move this group to the X and Y value that I have recorded in my documents. And there you go. So I can kind of just ungroup this. It was only to move my objects all at once. So if I move closer here, you now see that if I'm focusing on the roundabout, you see that I have a bunch of cubes that are representing my cars that I have recorded information in this traffic data information. So you see them moving here all along my animation cursor. But you'll see that if I go to the front view, this traffic data is all on the Z-axis set at 0. There's no height to this traffic data. It's only recording the X and Y axis. So I definitely want this traffic data to follow my roads. And there's a tool for that. So we'll go back to the top view and go under the Dynamite VSP menu, Traffic Import Surface Tracking Manager. Here you have a list of all the cars that have been imported. So obviously, you can either pick and choose the car that you want. If I select a certain car, it automatically gets highlights in the list of car here. So I can pick and choose which car I want to add surface tracking to it, or most likely you'll want to select all the cars. And what you want to do is start picking the surface that you want to track onto. So I'm going to just give you an example here by tracking to this certain surfaces. And tracking surface is a bit of a heavy process. So you want to make sure that you're only tracking the surface where your car is going along. So obviously my car is only going on the asphalt part of this surface. It's not touching the hard shoulder. It's not touching the ground type 1 or 2. Is only touching the asphalt. This is the only material ID that I want this car to be tracked on. So it's tracking on 212 faces. So right now I pick this particular surface, which is quite a bit of a long surface. So I can go in my scene and pick and choose all of the surfaces that I need my cars to be tracked on. But just for the example of this demo, I'm only going to track it to this surface, and I'm going to hit apply. So it's telling you, it could be a bit of a long process. And once it's complete, I'm going to be able to see the results. So if I go to the perspective view, and I go to a shaded view, you'll see now that I have some of these cubes that are tracked in this part of the corridor that I have selected. So if I move the animation cursor, you'll see that cars are now following this portion of the corridor that I've asked to be tracked on. And once they arrive at the end of the corridor, so you see here, they no longer have a surface to be tracked on, so they just disappear. If I go to wireframe, you'll see that they go back to 0, 0 where the information is. So once they're done with the surface tracking, they go back down. So you'll see immediately if you forget to track any surfaces, you'll see that the cars go back and they disappear. So it'll be really easy for you to understand if you've done this process right or wrong. Now, the second thing that you're going to want to do is probably you want to have these cubes transform into real cars instead of having cubes. We also have tools to do that. So we're going to go into the traffic import menu again and go to the vehicle substitution manager. So here there's two types of cars. There's the HGV car and there's the regular car. So for now, I'm going to select only the cars because it's the highest numbers that I have. And I'm going to select in the country kit. So you see here that you have access to all the cars that you have in your country kit, including the train that I've added. So this is also a good option. So for this particular example, I only want cars to be replaced by cars. So I'm selecting the list of cars, I'm pointing it, and I'm telling it to use random body colors. So it's going to have a different list of color applied to these cars. I'm going to select all the cars in the list, and I'm going to say update selected vehicle. So you'll see that it's going to use it in my list here. I now have the VSIM cars match with a certain type of vehicle that it's part of this car list here. So this is being applied randomly, and once I hit apply, it's going to be updated directly in my scene. And you see the result here in the file. So if I go to a shaded view, you'll see that there's no longer little blocks in my scene, that these little cubes have been replaced by actual cars. So if I go back to a wireframe and I move, you'll see that all of these cars are now replaced by actual cars. There we go. So this is kind of the process to deal with your traffic data information. And we're going to just load a file that I have placed everything in there. In this file, you'll see that all my traffic data information has been tracked on the surfaces. I've also cleaned a little bit of this data, so I don't have too much cars that are interfering with my Pemberton highway. So you see here, all the traffic data is following this road and there's no problem in here, and all the cars are moving and they're being tracked on the surface. So this is definitely adding validation to my project because I now have information on this exit road. So you see that I have a bunch of cars that are taking this exit. So it's definitely adding to the whole experience. So if I'm taking the camera that's driving down to the Pemberton road, you'll see that some of these cars right here, some of these cars are exit. It's definitely adding realism to the experience of my corridor here when I'm driving through and trying to find out what is this going to look like. Okay, so now that our visualization is quite advanced, we're going to start wanting to render some images and use them as presentations. So let's have a quick review on this, although I'm pretty sure you've done this if you have worked with Dynamite VSP and 3ds Max Design before. So I'm going to go quite quickly for the rendering setup of this still image, and then I'm going to go a little bit more in depth when it's time to render some animation. So first thing you'll want to do is definitely create a daylight system, because right now we have no source of light in our scene. So let's go to the top view to do that. Right-click in our Dynamite VSP Civil Explorer into the daylight and create a daylight system. So we're going to change it to mental ray photographic exposure control. Click once to create the compass and click a second time to create the icon of the daylight system. Now the daylight system icon is only a visual reference since the light source is going to be driven by the date, time, and location of the daylight system. And you'll be able to adjust that in the control panel of 3ds Max Design directly. So let's pick a location. So we know that this dataset was created in Europe. So we're going to pick Manchester, UK. And we'll set it to September 21st at 4 p.m. in the afternoon. This is only a preference. You can basically adjust the time of the day to suit your needs. If you need to adjust the orientation of the sun, i.e. the north, south, east, and west, you're going to have to select the compass and rotate the compass. So the compass is driving the orientation north, south, east, and west of the sun, and the source light is driven by the date, time, and location of your sun. So now if I go to my camera view, I will be able to render an image of that. It's going to go ahead and give me physically accurate sky, physically accurate sun, and soft shadow, and there you go. So we have the result here. this image took about, 23 seconds to render. And sometimes we want to do just quick, really quick render to test. Sometimes we need really high quality rendering in order to do a print. And the quality versus time rendering is going to be adjusted using the global quality knob at the bottom of the rendering window here. So first thing, image anti-aliasing, it's going to affect the edge of your object. So we're going to leave it to medium quality for now. For this particular image, it's fine. Glossy refraction, we're going to lower it because there's not a lot of reflection in this scene other than in the cars, which are pretty small in this image. We're going to leave the soft shadow precision to a default quality because we have quite a bit of soft shadow created by the sun on all of these elements. We're going to also lower down the glossy refraction precision because there's not a lot of glossy refraction other than in the glass, so there's not a lot of transparency in this image. And we're going to lower the maximum reflection to 1, maximum refraction to a number of 3, and click render again. So this should render a little bit faster now, and we can compare the time. So if you need to do a high quality rendering, you're definitely going to increase, for example, the anti-aliasing and maybe the reflection if you get really close to a car. And if you need to do real quick rendering, then you're going to, decrease the quality of these precisions, so you can have a really quick render and you can run a bunch of tests. So this render was a little bit quicker than the last one. For one particular image, it doesn't make a huge difference, but when it's time to render an animation and you're going to render 2000 frame, then the second that you're going to save per image are going to become minutes and hours at the end when you're accumulating all of these images that are being rendered. So this is something to keep in mind. The other thing that I'm going to adjust, I find that this image is a little bit dark because it's becoming late in the day, so I'm going to adjust my exposure control and I'm going to brighten up my render a little bit. So I'm going to lower it to 14. And I'm going to render just a region, which is something that you might want to do as well to save yourself some time. So render region is really good when you are creating some adjustments and you just want to test and compare one part of your render versus the other part. There's also options to render selected items, i.e. if you're adjusting a car color, for example, you can select only that car and re-render only that car in the rendering. So you can see here my render region that I have adjusted the exposure control to a brighter exposure is a little bit brighter, and I can easily compare it within these images, and that only took few seconds to render.